Alright, this is my video 3 for the Game Engine 2 Final Sprint submission. In this video, we'll be talking about the terrain class and manager that has been added to the engine. So starting off with the actual terrain object itself, which is this function here, we just have the constructor taking in the parameters from the user. We have this get object rectangle method, which you give a collidable and some address to variables that you want to store. That will give back the rectangle of the cells underneath you. We have public access to get the min and max. We have the actual model that is created of the texture, and then the graphics object that is used to render it, and then a wireframe that's used for debugging, and then we have some data that is stored and used later on in other calculations. And then just a couple functions that are used inside of the terrain itself for various things. But if we look in the constructor, taking in the height map file, texture pointer, and some variables that the user can set to customize the terrain. But we read the bytes from the height map file itself, which we will then use to set the Y value of the vertices on reading the alpha channel, so we're setting that by 255. We'll create 4 different arrays: pverts, trilist, min and max. These are the array of vertices, array of triangles, and then these are the min and maxes of the ABBs at each cell. The verts and trilists, after we create the model using them, will then be deleted since they are no longer necessary. And then the max and mins are actually maintained, and when deleting the terrain itself is when we will clean those arrays up. But we'll then go through and create our winding and create our triangles and set those in the trilist, which is used to create the model, and then we create the graphics objects using that model. Then we send an offset to make sure that the terrain is at the origin. This is the old highlight cell, which took in collidable. This has been replaced with the get object rectangle, which takes in collidable and some int references. We determine the min row and min column and the max row and max column, and we set those based off the floats that were the ints that we got. The get max and the get min can just return those values depending on what row and column you're looking at, and that uses that cell index function to determine what cell that is in that array. This is just the old intersect before we created the test terrain command, and then that's just to clean up the render, drawing the graphics object, and then those 2 functions, grabbing the index in the image and then grabbing the correct cell in the array of the maxes and mins. Then we have the terrain iterator, which has the current row and column as well as the min and maxes of each, and it maintains those values as well. Private entity. We have the terrain rectangle area, which the rectangle area will have the min and max as well for the row and column. And then here, when we create that with a collidable, is when we'll pass in that collidable with those values as references, and so those are going to get set when we call that function. And then you can grab the beginning or the end of that rectangle, ABBs or the cells in the terrain. Then we have the actual, in the collision test terrain command, we can see this where we create a terrain rectangle area based off that collidable, and then we run through each cell in that rectangle and we set our ABB to the min and max. We compute that data to update it, and then we run the tests with that. And so if we get to here, we're having collision with the terrain with our actual collision volume. If not, we're just getting collision with the B-sphere at this level, and then this is no collision with the terrain at all, but we're still drawing those cells that are underneath us. Then we have the terrain manager, which has a create function. You take in a name of your terrain and then all the functions or the parameters you would have normally when making the terrain, which will then call the private creating a new terrain object that gets stored in the resource map. Works very similar to some of the other asset managers. So you can do a create as well as a set, which basically just takes a name and will attempt to set the current terrain to that name inside the resource map of the created terrains. This is just a render terrain that's getting called by the engine. It basically is just trying to render whatever the current terrain is, if there is one. This is just terrain set, which is used when registering for terrain collision to check that there is indeed a terrain created. And then we just have the cleanup and the delete. But we're actually looking in the scene. Yeah, when calling the set collision terrain function to register for collision with the terrain, we'll use the isTerrainSet function to make sure that there is a terrain set that you would be able to collide with. If not, we're going to assert false and warn the user that there is no terrain to collide with. Yeah, we just have the load all terrains, which is just in the load all resources, which is where you would create your terrains. You can see in the collision test terrains command, when you hit intersect with the actual collision volume on your game object or your collidable, it calls collision terrain on the collidable, which is a new function for collidable. But we can see that in the player tank. So we're going to come back to the tank's collision terrain, and it'll just screen log collision with terrain. So if you run this, you can see we have those three cells colliding in the front. We get 3 calls of screen lock, collision with frame. And as we start hitting more, we'll see more popping up. It essentially gets called every time there's a collision with one of those cells with our actual ODB. If we get in a spot where there's no collision, you'll see them disappear. Yes, like that. That is the collision system, or the Turing collision system.